Okay, hello everyone. Thanks for joining us for the last CIIR talk of the semester. That's actually the last day of the classes here, and we are all excited. It's not just you students, we faculties are also excited about it. So it's my pleasure to introduce Michael Ekstrand, who basically came all the way from Philadelphia to here. Thanks, Michael. And so Michael is an assistant professor of information science at Drexel University. He leads the inertial lab, which stands for Impact, Innovation, Effectiveness, and Responsibility of Technology for Information Access. You all know Michael. He has done amazing research on recommender systems and its intersection with human and computer interactions and fairness, and also search engines and information exploited broadly. He has received a CIIR award in 2018 and other NSF awards, including the PopRocks project, which focuses on infrastructure for user-facing recommender systems. If you've heard of the Lens Kit, he's basically developed that and he's still maintaining that project. He created the recommender system, co-created the recommender system specialization on Coursera with Joseph Constant from the University of Minnesota, where he received his PhD. And almost all the fairness kind of evaluation campaigns that happened at Trek basically was run by Michael and his colleagues. So without further ado, please welcome Michael to UMass.
Thank you. I'm very happy to be talking with you today, sharing my work and perspective. I'll get to in a moment why sea monsters are in the title. My clicker is absolutely not working right now. That's fun. Okay, we can work with this. Okay, work with that. Yeah, so Hamid just summarized most of this, so I won't spend more time on this. I've been doing recommender systems for a while. Went to my first Rexis in 2009. But before I get into the research today, I want to take a quick skip through a few historical points. North and South is a novel written in the 1800s by Elizabeth Gaskell, contemporary of Charles Dickens, Jane Austen. And this book follows a young woman who moves with her parents from an idyllic agrarian southern town to a northern industrial town in England. And one of the central conflicts of the book revolves around the impact of industrialization on the community. The textile industry had industrialized. Industrial textile mills produced the community's nouveau riche. And the relationship of the mill owners and labor is a central concern. And particularly, one of the things that plays out in this concern is who gets to benefit from the introduction of this technology that is reconfiguring the manufacturing, the production, that is reconfiguring the economics and the politics of the community. Do all of the benefits accrue to the mill owners? Are the benefits shared with the workers? Are they shared with the community more broadly? In the 1989 CBC Massey lectures, Ursula Franklin took up a similar set of questions around the impact of technology on communities and, again, how the costs and the benefits of technology are distributed. And there are a few things that I take from her work that have influenced a lot of how I think about my own research. The first being to not just think of technology as the artifacts, the hardware, the software, the equipment that we produce, but technology as a process. And technology as a means, and the thing she was considered for organizing labor. As you introduce mechanization and industrialization into a manufacturing process, that imposes particular structures and organizations on that process and on the workers within that process. As we develop search technologies, recommendation technologies, generative AI technologies, those impose a structure and an organization on the information landscape and on the ways that people access, and it strongly influences the ways that people access information, locate information in that landscape. And many of the questions that she raised are still relevant today. Who benefits from a particular technology or a particular change in technology? Who incurs costs or is harmed by it? Do the benefits accrue to the people who accrue the costs? Who controls it? How is it, do we decide whether and when to deploy it? And who is it used to control? These are questions that are all very relevant as we think about information access because of that profound structuring impact that it has over our access to information and over our understanding of the informational landscapes. And a third piece is, when I first started in recommender systems, a lot of people in the community were talking about Chris Anderson's book, The Long Tail. And one of the central arguments of this book is that internet, e-commerce, access to global information spaces really increase the long tail of products, art, literature, beyond the most popular things and provide an opportunity to bring those things to a marketplace. And particularly that personalization and recommendation are the key to unlocking the economic potential of this long tail. And that by being able to match people who are creating new music, creating new art, making new products, with the customers, the audience that is going to be particularly interested in their products, we can promote economic opportunity. We can make a far wider range of production and cultural opportunities economically viable if we can do this matching. And that's a vision that captivated many in the community. It captivated me, and it's a vision I still believe in. So the research and the work I'm going to talk with you about today come from the question that keeps me up at night. Are we succeeding? Are we building technologies that are engines of economic opportunity, engines of equity in that opportunity? Or are we building systems that reproduce the same biases, the same discrimination, the same structural unfairness that has plagued society for much of human history? I don't think we have to reproduce them. The question is, do we? And so that's really been the driving question of my research agenda for the last 10 years, is to understand whether, are we achieving that vision? Where are we failing? What can we do about it? So this is not a new problem. One of the foundational papers on the questions of algorithmic bias and algorithmic fairness actually used as one of its examples a search problem, searching for airline bookings. And the system that was used, the systems actually, both of them, that were used in the 80s by travel agents to find flights were biased towards US domestic carriers. There were lawsuits, the Department of Justice got involved, that practice stopped, but just due to a prioritization to prioritize itineraries that were all on one carrier, it prioritized the US airlines because they have the connection from Bradley to New York as well as the New York to Amsterdam. And so KLM just has the New York to Amsterdam, so they would be on page 3 or 4 of the results. So this is not a new question. Questions of how do the ways that we build our search tool structure the information space and structure the economic opportunity through that information space have been live topics for a very long time. So why sea monsters? So a lot of this work, my talk today is going to be, a lot of it is going to be at a fairly high level with a few dives here and there and also fairly fast. But we've been doing a lot of work along with collaborators, particularly Fernando Diaz and Robin Burke, on mapping and understanding the space of fairness and information access. What are the different dimensions? What are the different problems? Because it's not one problem. It is a broad spectrum of interrelated problems. So mapping the space, there's been work on various parts of the space. there's a lot of points on the map that have very little work. And also, the landscape is constantly changing. And medieval map makers would often put sea monsters off in the map where it wasn't, we don't have no idea what's there. Could be a kraken. So I kind of want to do two things today. To talk about the overall map as a framework for locating particular problems, to talk about some of the work that we've been doing on some of those particular problems, and encourage you to go explore other places on the map and see if there's sea monsters, or see if we can figure out what's actually happening there. I also paradigmatically ground this work in a school of thought recently named called algorithmic realism. And the idea of algorithmic realism mirrors the shift from legal realism or legal formalism to legal realism in the late 19th century. And the idea is that understanding the theoretical properties and behavior of algorithms, models, et cetera, is not enough to really understand their impact in the real world. But we have to study what real systems on real data with real people used in real context with all of the other things that affect how they get used, and understand the impacts of those, understand the impacts of a system in situ, not only in a lab. The theoretical in the lab work is very, very important, but it cannot stop there. And if it does not give us a complete picture of how our systems are affecting people. There's a wide range of different ways that we can think about systems having impact, and we can think about systems perhaps being unfair or inequitable. There's some clear ones around discrimination. Information retrieval has long been concerned with various concepts of utility. We can also think about whether that utility is equitably distributed or whether our systems are delivering more value for some people or groups than others. Usability. Accessibility is a fairness and discrimination concern. If people cannot use our search system, cannot use our recommender system, they cannot get the benefits of the information it provides access to. Information access technologies can be used to manipulate people. How do we prevent that? How do we detect when it's happening? How do we understand the possibilities and the limitations there? And then a number of other concerns as well: isolation, filter bubbles, things like that, stereotypes, et cetera. There's a wide range of impacts, and each of which we can also think of on its own or in aggregate, and we can also think of in terms of how that impact is distributed on different groups of people and different stakeholders. So, as we started this journey into really trying to understand what it means to make an information access system fair, one of the things we found was, in retrospect, it makes sense, but at the time it was perhaps a little surprising. There's been a whole bunch of work on algorithmic fairness and general AI and general machine learning. Very interesting, very useful work. There's a whole bunch of definitions that have been come up with. But almost all of the vast majority of work, this is changing and has been changing over the last few years, but the vast majority of work is focused on classifiers in settings where you have kind of a traditional machine learning train test split. You have independence between your decisions, you have independence between your data points, you're doing it once, et cetera. Information access systems violate every single one of those assumptions in ways that mean we cannot just take algorithmic fairness concepts that have been developed for classification and other settings and directly apply them to information access settings. Because the first is that decisions are not independent. If we're doing a ranking, only one item gets ranked number one. The fact that we gave it ranked number one is also a decision that no other item gets ranked number one. But also decisions are repeated. The user is going to come back for more recommendations tomorrow. Another user is going to enter the same query. This actually gives us an opportunity to compensate for the first because we can put a different thing in number one in different queries. But it is a fundamental difference from what's been studied in the majority, or particularly when we started this mapping effort, from what had been studied in the majority of algorithmic fairness literature. Also, there are multiple stakeholders with different fairness concerns. In a lot of the literature, it focuses on one single obvious class of stakeholders, such as people applying for a job or a loan should be treated fairly. Not as much, there aren't as many other different stakeholders for which have a clear fairness concern, but in information access, we do. We have the users who are using the system to get information. We have the artists and musicians and authors and other creators that are creating and producing the products and the items that are being recommended. We have the subjects of the news articles, the participants in the trials, in research papers, et cetera, that we may want to make sure are fairly represented. So there's many different stakeholder classes. Also, in information access, there's a lot of personalization. The decisions can be personalized. In a recommender system, it's always personalized. In personalized search, it's also personalized. We're returning different results to different people. You don't want that in say a system that the bank is using to classify loans as high or low risk. You don't want it giving different answers to different loan officers. But in search and recommendation, we do. And also the outcome is personalized and subjective. For the same query, two different users with two different skill levels or two different backgrounds might have different relevance for the documents retrieved, as opposed to just the binary, like, is this person going to pay back their loan? And so all of these things change the game in terms of how we think about how we measure fairness and how we apply. Some techniques can be reapplied, but they need to be revalidated in this very different context. Also, there's not, in light of all of this, there's also fundamentally no answer. I cannot write down on the whiteboard a formula. This is fair machine learning. This is fair information access. Not only because we don't know what it is, but because it is fundamentally impossible. Fairness is a social and it is a contested construct. Basically, humans are never going to stop arguing about what it means to be fair. So we're never going to be able to write down a universal answer. So what do we do with that? Two moves my collaborators and I have been making, and I've also seen being made in the broader fairness community as well. The first is for this information access, we're moving from decisions on subjects, should you get the loan, to this complex, multi-stakeholder, multifaceted, personalized landscape. And the second is from general goals to identifying, measuring, and addressing specific harms. So we've started talking a lot more about fairness-related harms rather than fairness in general. And that concreteness and specificity helps us better navigate some of the different trade-offs that have been discovered. It helps us more precisely define the problem. It helps us, provides a lot of clarity to help us navigate and understand what we're doing and then position it with respect to the other things. So building on algorithmic realism, the paradigm we bring to a lot of this research is that a lot of effective fairness, especially if we're going to be trying to make actual impact on systems, addresses specific harms in particular contexts. And then after, I believe that as we address more and more specific harms in specific contexts, we will be able to inductively or from the ground up build up an understanding of what generalizes and what doesn't, as opposed to, I think the fairness community kind of got stuck for a little bit of trying to be very general from day one when that wasn't going to work. And so identifying the specific on the ground problems, building up from that, I think is a more promising approach to generalizability. So we want to work on a specific problem. How do we identify it? How do we locate it? There's many different dimensions on which we need to define a specific problem. And so three particularly important dimensions, we write about this in our Foundations and Trends paper, is the first, identify the stakeholders. Who are we worried about being harmed? Consumers, providers, subjects, society at large. This applies broadly to impact questions, not just fairness. On what basis are they being harmed? Are they being harmed on an individual basis? Are they being harmed on the basis of their identity or of their group membership? This applies both to the protected characteristics that have long been considered in US anti-discrimination law. It also applies to some that are perhaps more specific to information access. Is a book recommender providing fair opportunity to new authors' first books? Or are most recommendation lists primarily the third, fourth, and fifth books by established authors? We could think of new author or new artist as a protected group that we might want to consider fairness towards. And then how are people being harmed, or how are we concerned about them being harmed? Are they being denied resources like opportunity for people to see their product, quality search results and recommendations? Are they being misrepresented or stereotyped, etc.? And so the first step really is to identify where on this map your problem is. That helps you then identify how it relates to other problems. It helps you scope what problems are you not solving right now, so you can work on solving them in the next project. And that then goes through a process. So I'm going to go quickly through this, but Jesse Smith and Lex Beatty have been doing some work on, like, concretely, what is the process for building up a fairness project or any social or algorithmic impact project. And they start with scoping it out in terms of the scale of impact, the type of impact, and the distribution of impact, some of the aligning with some of the questions I just talked about. And then once you identify that goal, then mapping it to an operationalization. And starting with the goal first helps you really have the direction of what you're trying to solve. And it also gives you a framework to understand what your operationalization loses, which then is a great place to look for your future work section in the next project. Because so thinking about, as you're doing this, you have your goal, you work down to the thing you're actually measuring, the thing you're actually improving. Keep a record of all of the things you get lost along the way, both so you can properly report them in limitations and in future work, and also so you can plan the next project around them. And also so you don't fall into the trap of thinking that because you solved the operationalization, you solved the original problem. You hopefully made progress, but social systems are complex. Solving any one operationalization rarely solves the whole problem. So it gives us a context to contextualize and properly report on and think about what we're doing. So you identify the goal, design the operationalizations, and then select intervention sites and strategies, and making sure that they're well aligned, because not all goals are best mapped by improving your dense retrieval model. They might be best served by improving the user interface or investing in higher quality data. I'll talk a little bit more about that later if we have time. So with that in mind, a quick warm up to show some of the kinds of impacts that we can see. So this is a paper that I did with Fernando and with Ben Carteret on looking at distributions of effects and of utility in recommendation, also applies to search, results, not just point estimates, and looking at distributions over a range of things: stakeholder classes, users or groups, or providers or groups within the stakeholder class, distributions over uncertainty, say uncertainty in our relevance judgments, uncertainty in our model outputs, if we have randomization, multiple runs, all kinds of different, like a chunk of the paper is just laying out where all in recommendation do we have the possibility for a distribution, and looking at both aleatoric and epistemic uncertainty. So epistemic uncertainty is uncertainty in what we know. It's when we're using probability to encode degrees of belief or degrees of confidence and knowledge. Aleatoric uncertainty is uncertainty that arises from the randomness of the process. We don't know what user is going to use our system next. That kind of thing. One of the things we found there is when we had a little case study in there that just looked at a couple of recommender algorithms, and their top order performance metric was the same. No statistically, very small, but not statistically significant improvement. But when we dove into the distributions, we found that the slightly better model had better performance for female users. That very small improvement was almost all improving things for female users. It had better distribution of exposure across the different movies, both at an individual item level and at a group level, and that these improvements were stable across multiple different browsing models in the evaluation metrics. So that, the mean is the same, hid that one of these algorithms was actually advancing several important goals in a substantial way. And so it would be worth deploying even though the top order metric didn't show that. And so when we dive in and we understand how the system's impacts are distributed across the different affected people, the different runs, et cetera, we get a much richer and more thorough understanding of what our system is doing. So, provider fairness. This is the one I've probably done the most work on. Provider fairness, we are concerned with being fair to the providers, authors, artists, creators. It's the people who are creating or producing the items that we're recommending or the documents that we're retrieving. And so in this paper, we were looking at book recommendation, and we were looking at gender representation across the pipeline, from a corpus of books to users' individual collection, reading histories, to their recommendations. One of the big things we found is that collaborative filters propagated gender patterns. If people read more books by women, they were recommended more books by women. In some ways, this is unsurprising. Pattern replicator replicates pattern, news at 11. But all of our models are imperfect pattern replicators. Understanding how those imperfections interact with real data and real applications helps us understand their consequences. If a model is bad at picking up a pattern, but that pattern is a bias or a discrimination that we don't want in the system, that imperfection might actually be useful. And having an algorithmic, the principle of algorithmic realism is that we do need to understand and measure what's actually happening with these things in real data and real context. Now, we did not have the opportunity to actually go to users getting the recommendations. So it's partial algorithmic realism. But measuring what the system's actually doing in real contexts. We also found that if we just forced the recommendations to be balanced, we didn't hurt our accuracy metrics too much. And user profiles were more gender balanced than the Library of Congress. Also, the data for this, or the tools to do the data integration for this from public sources you need to download, are all available. So if you have a project where book interactions, book ratings, book reviews combined with book metadata, combined with author metadata, including gender identity for a bunch of authors, would be useful, I have data. But with mapping of goals and operationalizations, this had a little bit of a problem. It's an interesting study. Looking at representation is important, but the original problem I was interested in was opportunity. So there have been a number of efforts to try to improve representation of women in book authorship. And my question was, okay, suppose that's successful and we have a bunch of women who get a new book contract and write and publish their first book. Then their book goes on a book recommender. Does the book recommender help them find an audience? Is it just neutral, or is it yet another hurdle to having a successful career as an author? But we didn't really measure that. We measured representation, but that goal was really exposure. So that mismatch led me to join a team working on some exposure questions, because search and recommendation results expose content that then provides a number of benefits to the creators of that content, the producers of that content. There's a number of different perspectives, therefore, on fair ranking. Fair representation, we just talked about. Fair exposure, another one, fair accuracy, that I don't really have time to talk about. We talk about these in our CIIR 2022 paper, led by my former student, Amma Faraj. But the fundamental problem, one of the fundamental problems with exposure is if we've got some search results, maybe they have a relevance curve that looks about like this, our exposure curve typically drops off a lot faster. And so these two pictures have the same relevance, but a significant difference in exposure. And if they continue to be retrieved in that order, that's going to really add up over time. Further, if we don't properly debias our click feedback and we learn from that, the system can learn that they're different even if they aren't, or a 2% difference in relevance then can get magnified to a 50% or more difference in exposure. So it can really amplify small differences. It can make the system learn poorly. So when we think about exposure, this work led by Fernando, also with Bhaskar Mitra, Asha Bega, and Ben Carret, we looked at this exposure and proposed, particularly in stochastic rankings, where the ranking is being drawn from a probabilistic policy instead of a deterministic ranking, and proposed the principle of equal expected exposure. Given a fixed information need, two things with the same relevance should have the same exposure. You can only achieve this in expectation over repeated rankings. So this operationalizes a type of goal called equality of opportunity. Given that two documents are relevant, they should have equal opportunity to show up in the list to get user attention on them. And that opportunity, if we think about it, say, in terms of groups, the probability of a news article showing up in a user's search results should be conditionally independent of, say, the author's gender, given its relevance to the user's need. Given its relevance is a huge caveat there, but that gives us a principle to try to shoot for. So we operationalize this idea by computing the system exposure from the policy or from repeated rankings, computing a target exposure under an ideal policy. We used a simple ideal policy, which is under binary relevance, all relevant stuff is at the top. But within that, all rankings satisfying that are equiprobable. This, though, is a reconfigurable thing. If you have another objective, you can plug in a different target policy. Maybe you want to prefer things that have higher diversity at the top of the list. You can reconfigure the target policy, and the overall metric tells you how far you deviate from it. We then just compare the target and ideal exposures. We can use this either as a metric. It does have some interpretability and scale problems. It has the same basic problem as KL divergence. Given a fixed target, you can see which system approximates it better, but you can't compare those numbers across different targets, or you can use it as a learning to rank objective. So there's a lot of different metrics out there, though. Our CIIR paper looked at a number of them and particularly identified some of the key considerations you need to think about in terms of determining the metric. And this is after you've located. I care about provider group fairness, equality of exposure. You still have decisions to make. Are you looking at one ranking or a distribution of rankings? Are you looking at fixed known discrete group membership or mixed are you allowing mixed membership or uncertain membership? Do you have two groups or do you have multinomial groups? And we identified in their expected exposure and then another metric called attention weighted rank fairness that work well across mixed membership and multinomial groups that seem to be generally useful. Alpha then went and asked, well, okay, we did all of this on ranked lists, but Netflix doesn't show me a ranked list. Netflix shows me a grid. And it turns out that there is annoyingly little research on how people actually interact with grids in a way to give us, say, grid-aware evaluation metrics or grid-aware browsing models. So what we did, we took the metrics we were using, rank bias precision and either expected exposure or attention weighted rank fairness, and we just swapped out the browsing model with a grid-aware one based on the literature that was available to ask the question, if we have something that's fair on a ranked list, is it still fair on a grid? No. That's the short answer. Like the basic takeaway here is when you're measuring fairness, you need to, your result is going to be dependent on your specific layout and geometry of the results. Then introduced a simple grid-aware re-ranking technique. And found when we do that, we get better performance on the grids, but you have to target your specific grid size. If you target your grid layout that you're going to have on your set-top box and your tablet has 2 fewer columns, it's not necessarily optimally fair anymore, which is annoying that we have to take into account what our actual geometry is to achieve optimal fairness, but we can't. These things are very, very sensitive to how we're going to how we lay things out in the final results. A lot of the things that apply to fairness mathematically also apply to subjects, the people or groups that the content is about. And it also winds up being conceptually similar to diversity, because diversity, item fairness, subject fairness, mathematically or data-wise, they're all looking at what happens with regards to different attributes that are attached to items or their providers. But they have a number of different conceptual or normative foundations that then yield different evaluation approaches. Are we trying to provide fair exposure to different items or topics? Are we trying to provide an accurate representation of the information space, either the actual information space or the hypothetical information space? So the example that gets used a lot of what happens when you do image search for CEO. There's 2 pieces. What is the landscape in terms of gender, ethnicity, et cetera, of CEOs? And what is the landscape of who could be a CEO if the world had no bias or discrimination in it? Those are not the same thing. But thinking about either of those potential targets, we might have the need to satisfy diverse needs or query interpretations and a lot more things, but these different concepts, even though they look similar, and one of the things that means is you might be able to use a diversifier to get fairness. The Glasgow team had some good success doing that. But you need to evaluate it in terms of the actual goal you're trying to achieve. So that's provider. I'm going to quickly talk about some consumer. We're looking at how people, again, the same set of problems, except now we're looking on the consumer side, the people using the system to get information. And I use the term consumer instead of user because from an HCI perspective, like you go to Spotify, both listeners and artists are users. They have an interface they can use the platform. So consumers, to clarify, we're talking about people who are using the platform to obtain information, products, services, et cetera. So the kind of the general fairness goal might be to ensure that consumers are treated fairly in all relevant aspects of their experience, which has a number of sub-goals: utility, usability, representation, et cetera. Equality of utility is one that's commonly pursued. I've done some work on that in recommendation. There's also a search paper on that by Rishab Mehrotra. But looking at, do different groups of users get comparable utility from the system so we don't systematically underserve users? The key thing to do there, you start measuring disaggregated performance by group. The data to do that in a public and offline way is hard to get, but if you're in a company, you can often get a lot more of it. But then this is where the matching between intervention and action comes into play. The solution is not necessarily to throw a regularizer on that difference. The solution might be identify why that group is getting bad search experience and prioritize development to give them a better experience. So then you don't run into the situation of just making things arbitrarily worse for a group that has good results. Their good results aren't why this other group is getting bad results. Understanding the specific contours of the problem. And so this is a case where we run into what economists call subtractable or rivalrous goods. And a subtractable or a rivalrous good is one where people compete for it. And if I have it, you don't have it. Or if I have some of it, that's a piece you don't have. Given a fixed query flow, provider-side exposure is rivalrous. Anything that gets one slot, nobody else can have that particular slot. But consumer-side utility is non-rivalrous. My bad utility and your good utility have nothing directly to do with each other. And so zero-sum solutions can be appropriate for rivalrous settings, but not for non-rivalrous. Wang and Joachim's have an interesting paper that provides an interesting positive sum consumer-side fairness objective to address this. All of the citations are on the web page that I have a QR code to at the end of the deck. So we have a lot of we can think about unfairness with regards to utility. We can also think about unfairness with regards to the composition of the result set in a number of different ways. Sophia Noble looked at this in regards to both stereotypes and the picture of the information space. And what picture of reality and of human possibility gets presented to users. And then also we can think about direct misrepresentation. More student work. Amapha did this piece as well. She did a lot of interesting work when she worked with me. She's now at Microsoft evaluating Bing. So she was looking at gender stereotypes in search results for children's toys and products. And there's been a bunch of research on the influence of early childhood exposure to gender stereotypes on childhood development, et cetera. There have been campaigns to reduce childhood exposure to stereotypes. Target has changed the layout of the toy sections of their physical stores to reduce the gender stereotyping in them, and no longer, like, the aisles still might be a little segregated, but they're no longer labeled boys, girls, et cetera. So we wanted to understand how much do these stereotypes show up in search results. So we went and we measured Target and Amazon and a few others, but these were in the paper. So from previous literature and advocacy campaigns on stereotypes, Amapha got a list of different toys and their cultural gender stereotypes, at least in US culture, Anglosphere culture. We took each of these and we turned it into a query, fed it to the system to see what came back. And so we looked at query suggestions. So if we type in toy for, and then we look at the query suggestions that come back, and we count the gendered terms. How many of the query suggestions mention one gender or another? And what we found is, yes, a lot of toys cough up. You'll see more of one gender than another in the query suggestions, and those aligned with our list of the correlation between that and our list of cultural stereotypes from the previous research was high. So if we accept this as a reasonable first approximation, it's one of the things where, like, my whole career, I've really liked working on problems where nobody's measured it before. So we don't know how to measure it. So the first thing we have to figure out is how to measure it. So we were looking at, we don't claim this is the ultimate way to measure. We were looking for the simplest thing we could do that looked sensible for trying to capture this concept. And so we found that alignment. We then looked at search results. And for each toy, we ran 3 queries. Superhero toy for kids, superhero toy for boys, superhero toy for girls, keeping them structurally similar so we didn't have like no 4 plus 4 mixing things up. And then we looked at the list of just the set of toys recommended, and we computed the card similarity of the toys between the gendered query, each of the gendered queries, and the non-gendered query. Under the principle that if the non-gendered query was much more similar to one gendered query than another, then that's evidence of a gendered association between that toy or toy category. And and we found the same thing. We found the stereotypes propagating into the search results. That's published in CIIR Ecom. I don't remember if it was 2022 or 2023, but so a number of these things have been on gender. Another piece we did that we published in CIIR was a systematic literature review of how gender has been used in information retrieval research and connecting that with recommendations from gender theory and from HCI around how to responsibly and ethically use gender in research, and have some recommendations around how to practically make use of gender in ways that are not trans-exclusionary, that respect individual autonomy, identity, et cetera. So I'll refer you to the paper for a lot of those details there. Talked about intervention sites. Here is, this is something that I'm going to talk about quickly, but the key idea is there are many, many different places in the system that we can intervene. Algorithms and models are just one piece. Intervention to improve fairness, to address an adverse impact can happen all across the different ecosystem. This is from our ECIR 2024 paper. We can intervene by improving the data, either investing in higher quality data, more data, et cetera. The algorithm itself, the design, the interface that the system's being wrapped in. The evaluation, that can be an intervention, like you get what you measure. So if we take care of what we measure, we update what we measure, that's gonna have effects on what we build, what the models learn, how that goes into production. The engineering process itself, you don't get a paper for we reprioritized our sprint, but just using fairness concerns or impact concerns to influence your prioritization decisions in product can be a powerful tool for improving the equity of a product in real life. And then broader marketplace things, new products, competing products, like Spotify introduced Spotify Kids to provide an experience for music recommendation, particularly tailored for children, so they could have their music needs met, et cetera. A lot of different things we can do. So as I get towards the end, generative things are taking over the world. So I've talked a lot about ranked lists. What happens in the generative world? Because a lot of things seem like they're changing. We go from a ranked list or slate to generating explanations, generating lists. We have a lot more sophisticated embeddings. We're maybe generating queries. A lot of different things. We're generating a lot of things. This keeps all of the old harms, and it can introduce new ones like fabricating facts, the economic impact of replacing human creators, lots of opportunity for stereotypes, bias, discrimination, et cetera, to creep in, et cetera. Many, many different things, a lot of which we don't even know how to measure. And even the ones we did know how to measure, okay, I can measure equity of exposure in a ranked list. How does exposure work in a RAG result? Do we know? How do we measure equity of exposure of the results that are showing up in a RAG? And particularly translate that to the kinds of things about exposure that creators and authors care about. There's a lot we've done a lot of work on measurement, and there's a lot that needs to be redone or expanded or extended to really address things in this world. But a lot of things remain the same. The core questions of understanding what the problem is remain. We still need to locate a problem. This precise problem might change, but we still need to ask the same fundamental questions to identify what problem we're looking at. And also grounding in understanding the reason we're supporting retrieval, search, recommendation, gives us then an anchor for thinking about what kinds of problems we're going to try to solve and how we might go about them. So if we're interested in providing a marketplace that provides opportunity to creators, then that's going to influence both how we determine what kinds of retrieval and technologies to deploy, and then also the problems we're concerned with and how we go about measuring them. Also, though, something that is a fundamental change is that recommendations and search do not just connect people to products and information, but they connect people to people through that product or that information. It connects you to the author of the news article, to the author, to the artist on the song, in ways that provide those exposure benefits that we talked about, provide awareness of who's on the other side of this thing. You'll see this fairly explicitly in some of the early recommender systems work in the 90s. They were very concerned with the community and the social aspect of recommendation. Oh, this slide, I have a C. Muñoz keynote, but this slide originally came from a talk in which Muñoz had given an earlier keynote. So go see Muñoz's keynote from the Rojan workshop at Rexus last year. That's what that is. Or no, Muñoz keynote at Rexus last year. So the video of that's online. But when we introduce generative retrieval, at least if we're not careful, we're no longer connecting people to people. The system is interposing itself when we're connecting people to system. In the lens of Cory Doctorow's enshittification, it's that last stage of the system taking all of the value for itself, if we think about the economic value of the exchange. And so is this fundamental change? Sometimes that might be useful and appropriate, but we need to recognize that that's what's happening, and that's going to affect then how we think about and understand the consequences of what's happening. But also, fairness and harm, as I said, is highly contextual, highly application specific, but we have these large pre-trained models we're trying to use for a large number of cases. What actually applies in a general sense? And we cannot assume that fairness or social impacts compose. Making one step more fair does not mean the whole chain is going to be more fair. Your downstream might learn to re-add. Humans and algorithms do not compose. There have been results showing you take an algorithm human process, add a fair score. The human decisions are less fair, or they can be. So the generality and the composition, we have to really understand these on an application by application basis. So there's a lot that changes with generative recommendation, generative retrieval, et cetera. But a lot of the fundamental questions, who's being harmed? How are they being harmed? What do we want to do about that? Remain. And I think that gives us a lens for navigating how we understand the changes. Think also about what's not changing, and then how we build from that and adapt it to a changing technical landscape. So to wrap up, a couple of things I didn't really have time to talk about in more detail. One, news recommendation. We're building one. You can use it soon. So this is an NSF-funded infrastructure project to provide the opportunity to run experiments on news recommendation presentation, et cetera, with real people who have consented in to participate in that human subjects research. So if you've got a news recommendation idea, or you've got an NLP thing for how we present the news, and you want to run an A/B trial, you want to run a trial where users tell you what they think about it, our goal is to provide the platform for you to do that. We currently have our MVP up and running, an email, a daily email personalized newsletter of AP News. We're going to be launching our first experiment next week or the week after. This is not just for us to run. So us, it's Minnesota, Colorado, Drexel, Clemson, and Northwestern are all involved. But it's not just for us. This is for the broader information retrieval recommendation NLP community. So if you've got interesting user recommendation experiments you might want to run, get in touch. We've also been doing work on search for teachers, particularly to help teachers find readings for their students to read in the classroom, to have a more varied set of readings, understand how the classroom instruction topics relate to their lives. This is currently in the we're trying to get money stage, but there's a lot of complex, it's a very complex retrieval problem in some interesting ways. Also some open source tools, recommended research tools, the book data that I talked about, scripts, reproduction for a number of the experiments I've talked about. So think about the dimensions. Think about the places in the map that haven't been studied. Where does the map currently say sea monsters? There's a good thesis topic. And understand how they relate to each other. Some directions I'm thinking about is looking at the whole pipeline, looking at how to measure some of these problems we haven't figured out yet, how to actually turn these measurements into practical debugging tools. My recommender failed its fairness audit. Why? What can I do about it? And then some more of the social principles. Paper hopefully forthcoming, and we submitted a minor revision, so I expect forthcoming in TOR soon, looking at how do we involve people who are not information retrieval experts in designing the systems they use or the systems that are going to affect them. So clearly identify your problem, understand its relation, and join me in expanding the map. Thank you. Happy to take questions.
So, one question I have is, so you're now seeing a lot more sequential recommender systems like or instead of locate and things like that. And I'm wondering if because you're giving feedback one after another, and these are basically action related in one system, would that change any of the way that we have to measure these policies or these various issues for training our model?
Yes, I think so. When you have that kind of a sequential interaction or a streaming, a similar set of things is going to arise in like streaming radio. That's very different interaction than a ranked list or even a grid. And what does exposure mean? How do we think about measuring that in that setting? Is, to my knowledge, an unsolved problem. So yes, I think it does matter. And I don't think we have a good handle right now on what the right definition of that is. I do think it's going to be stochastic or amortized over a sequence of interactions or a collection of user sessions to really understand it. I think you can get at there with, like, if you've got all of that scroll data, you can look at both impressions and then whole or most, like, how many users did this did this creator's video get in front of who watched at least 75% of it? So you can measure that if you've got the scroll data, but if we're trying to do, say, then an offline evaluation, translating that into what it means for it to be an exposure model is an interesting unsolved problem, so far as I know. I think it would start with that probability of getting I think expected exposure is still the right way to think about it, but figuring out how you quantify that exposure and properly compute the expectation, I think, is unsolved.
Fairness and representation of recommendation. You're running into problems where you're trying to balance representation, whereas there might be something intrinsic in what you're looking for that depends on the thing you're trying to balance. Let me give you an example. I want to look for books about Black experience in America. Probably the best books about that are going to be by Black people in the novel. And if you're trying to sort of balance all of the diversity authors that are represented in one person, are you going to somehow choose the results of what you think?
Yes, probably. So that gets actually to another interesting unsolved problem of kind of the meta question of, for any given query, for any given session or interaction, how do we determine which fairness treatments are appropriate in that context? And that is an important problem because they aren't all going to be universally appropriate. And so, yeah, diversifying that query is probably going to hurt its utility and its social impact. Another one that came up when we were working on the Fair Trek track that we solved just by removing the navigational queries from the data set is a navigational query. You probably don't need fairness, at least for item 1. because the navigational query is supposed to retrieve the item you're looking for. You don't want to mix up that item with others just for fairness, but you still probably want to look at what are items 2 through 10. Just in terms of that's going to affect what people see as related to the thing that they're looking for. And are you equally effective at solving the navigational query for different provider groups? Or is it a lot better at navigational queries for some authors' work than for other authors' work? And so different query types, different subject matter, different topics are going to need different fairness treatments. And so far, the literature has not gotten to the point of effectively trying to identify which ones are needed in a specific case and activate them. That's a really interesting and important direction that I think a lot of this work needs to go, is to be able to identify, what's actually needed or appropriate here. It also balances with, say, users' preferences and interests, because we don't want to just override the user's interests either. And so it's also not all or nothing. It might be like, okay, so we're incrementally more diverse than the user's interests, but not throwing out their historical interest profile. But there is a lot of subtlety that does not yet have clear answers, but it is an important problem. But for fair track, we just threw out the navigational queries. Other questions? Yeah.
Can be used to come up with user models or like more diverse user models to study the fairness of results, search results, or economic results, or they have higher chance of introducing their bias in modeling methods?
So my default assumption is that they're probably not going to make things better, and they might make things worse, but that's mostly a function of their training data. And the different biases and stereotypes, et cetera, that are going to be in the training data. I think one of the things that may be potential, I think they have a lot of opportunity for really being able to engage in dialogue with the user to understand their preferences, if we can then translate that into a computationally useful, and maybe the computationally useful preference model is just a prompt, but I think they have a lot of potential to give users more autonomy about the system's model by engaging them in a dialogue, if what it is telling them about its model is actually faithful to the way the model is really working. But on their own, if we just feed it data about the user and don't do anything specific, I don't have a reason to believe that it would be better than, say, collaborative filtering techniques. I also don't know empirically that it would be worse, but there's a lot of work definitely yet to be done on fully understanding like the contours of what's happening, what kinds of biases, social biases, et cetera, are in the models. I do have a lot of skepticism about using them on the evaluation side. I see that done sometimes, about like prompting the model to respond as a Black man or something. And I'm very, very skeptical of that side of it, because there's so much about living life in a particular social location that's not captured in the model. And that can't be, because the data doesn't exist for it. But on the actual user modeling side, I think they can be a tool for at least allowing users to exert more control of the model. But I think we're kind of in the early stages of figuring out how to do that well.
Recommendations like during the election season, noted that I was usually being shown whatever I did. So that is why there was more proof as to like what is going to play out, what's true, and there was a lot of polarization seen across, and everybody kept being reinforcing their own. So how do you plan to tackle this kind of lack of truth kind of interpretation?
So in general, it is a hard problem. The way we're solving it for our news recommendation platform so far is through policy. So right now, we're only recommending AP news. pretty neutral down the middle of the road, pretty reliable factually. And in the near to mid future, we're planning to take a conservative approach to what news sources we add to the corpus. So far we're adding that to, we're addressing that by focusing on reputable, mainstream, widely respected news sources. So we don't have to solve it at an algorithmic level. At an algorithmic level, there's been some interesting work on what's called bridging algorithms that try to identify articles that are going to appeal to someone and pull them closer towards a middle. I've got, the work is technically interesting. For me, there's a number of social and political questions around how you actually deploy it in practice. Particularly the extent to which it assumes symmetry versus it engages with asymmetrical polarization. But from a technical perspective, there's that's kind of the first place to go to look at trying to address it, coupled with understanding the symmetry or asymmetry of the polarization in your particular landscape. Oh, I see one more question, but
follow-up with that. Do you see the policy that will be implemented, not specifically as far as, being implemented by active populations, make fair?
A little. So I know that Spotify has used some of my methodologies for audits and internal measurement. Spotify folks have told me that. I've also heard generally in at least one other firm of my work is having impact, but no specifics. So yes, I see some of it. Perhaps not as much as I know, and there might be some that I don't know about. But yeah, I do see some of it. And that's kind of my goal. Like I focus a lot of my stuff methodologically. For a lot of this, my win condition is that, yeah, the tools are there. So if someone at Spotify, someone at Goodreads cares, they now have tools they can use to go and actually measure and hopefully nudge them to care. So thank you.
For coming. And this concludes our CIIR class.